All right, inverse functions, not bad, I promise you that. So inverse functions undo each other. So here's the basic idea. You're going to flip the x and the y, and then you resolve it for y. So when you put one equation in for x and the other equation, it all comes out to x. You'll see it, it's very exciting. So inverse relations, if you're given coordinates, like which your coordinates are x then y, you just flip your x and your y coordinates. That's it. So if you look at example 1, the given coordinates are on f of x. Find the coordinates for f inverse, that's what that little 1 means there, of x. Legit, all you do is flip the x and the y coordinate. So on A, the x becomes 4, the y becomes -2. That's it. So on B, 4, 7, the inverse coordinate of that would be 7, 4. So eventually, if you were to be graphing these, it's like they get reflected across the line y equals x. So if you had like a ghost over here, woo, woo, it would get reflected over yonder. Woo, woo. It's time for Halloween, folks. It's Halloween time. Oh my gosh, now they gave us a table. All we got to do is flip the x and the y coordinates. It's just that easy. But we're going to list them as coordinates. So here's how we're going to do it. We're going to do the squiggly bracket, and then we're going to list each coordinate. So this original coordinate was 2, -7. The inverse coordinate, we can write f -1 of x. That's inverse. So we could say -7, 2. Then we're just flipping. So it was 5, 3. Now it'll be 3, 5. It was 0, -10. You bet. -10, 0 now. Oh, don't even tell me -4, 1 gets flipped. It does. 1, -4. Very exciting. Very exciting. Oh, goodness. Here they listed them for us. Let's list the inverses of them. 1, 7 becomes 7, 1. 4, -3, you know it's -3, 4. 9, 11, never forget to reverse your coordinates as well. 11, 9. And then -2, 5 becomes 5, -2. There we go. Alrighty. Here's where it gets fun and exciting. They're going to give us equations, and we're going to have to find the inverse of that equation. So again, all we're going to do, if you look, we're going to rewrite the function with y if needed. Usually it's listed as f of x, but just picture it as y in your head. Thank you. We're going to swap the x and the y, and then resolve it for x. And then we're going to rewrite it at the end in inverse notation. So look at A here. The grade you're all going to get on your next quiz. Now this says y equals, so we don't have to replace f of x with that. So we're going to flip the x and the y. So our new equation is going to say x equals 3 over y minus 2. Now this is a doozy. Here's what I think would be easiest on this. Turn this into a proportion. So x would be x over 1. And remember, with proportions, you can cross multiply. So we're doing x times y minus 2 equals 1 times 3 is 3. Which, that seems obnoxious, but we're going to get rid of the x right now. So x is being multiplied here. We're going to divide it to cancel that out. So we have y minus 2 equals 3 over x. And then we don't want the minus 2 there. So we're going to add 2 to both sides. Plus 2, plus 2. I'm going to move down a little bit. All right. So we'd have y equals 3 over x plus 2. Now that's it. But we're going to write it with our new inverse notation. So we'll replace the y with f inverse of x, right? That's it. Equals 3 over x plus 2. That's probably the hardest one we have today, honestly. So here y equals negative 5/8 x plus 10. Flip it, x equals negative 5/8 y plus 10. All right, I mean, you can get rid of the fraction first, or you can subtract the 10 to the other side. Now, if you just have a fraction in front of your variable and you're trying to cancel that out, you could certainly divide by negative 5/8, but when you divide by a fraction, you really multiply by the reciprocal. So that's what we're going to do. We're going to multiply both sides by negative 8/5. So that will just cancel out the negative 5/8, and we'll just have positive y on the right side. But remember, we're doing an inverse notation. So I'm going to replace the y with f inverse of x equals, and then we'll just distribute this. So negative 8/5 x plus, because we have a negative times negative, 10 times 8 is 80, divided by 5 is 16. These are pretty tough, pretty tough. Now let's just send them all off the page. How about that? All right, 2 minus x over 3. Replace it. So now we'll have x equals 2 minus y over 3. We can get rid of the 2 by subtracting it. Negative y over 3. Now, we can get rid of the divided by 3 by multiplying by 3. But that's going to give us negative y. We want positive y, so we can get rid of the negative by multiplying by negative 3 on both sides. So the right side would just say y equals, which we're going to use our inverse notation for. Over here, we distribute that negative 3. Negative 3x plus 6. All right, last one. Replace, swap them. If you'd like, you could totally distribute the 4/5 to both of those. Unnecessary. We're going to multiply both sides by the reciprocal now to cancel that out. 5/4. 5/4. So we'll have 5/4 x equals, and the 5/4 just cancels out the 4/5 in front. So we'll just have our y minus 15 left. And then how do you get rid of minus 15? You add 15. So we'll have 5/4 x plus 15 equals y, but I'm going to replace it with our inverse function. Now, if you were to have distributed that 4/5 first, I promise you it still works out to the same thing. Eventually, you're going to have to use that reciprocal, that 4/5, but you'll be all good. Yep. And then the last thing, inverse functions unknown each other. So sometimes you're going to have to evaluate them and see if it comes out to just x. If you plug in one function into the other one for x, which just seems weird, and it works out to x, then yeah, they're inverses of each other. That probably sounds way more complicated than it actually is. So here's the idea. F of x and g of x. We need to verify that they are inverse functions. So what we're going to do is we're going to take one equation, and it doesn't matter which one. So let's say I took this equation, the x plus 6, and I'm going to put that in to g's function. So that would say g of x plus 6. Now when you're doing functions, this x plus 6 is going to go in for any spot you see an x in the formula. So it was x minus 6, but we're replacing x with x plus 6. So it would say x plus 6 minus 6. Great, we replaced it. So x plus 6 in parentheses, the parentheses don't really matter. And then the 6 minus 6 cancels out, so we're just left with x, which is what we want to prove that they are inverses of each other. Right? It seems wild. Now we could try it the other way. We could take g's equation and plug it into F's equation. So we could say F of x minus 6, and again, it replaces the x in that formula with x minus 6. Cool, so it's a x minus 6 plus 6. Which again, the negative 6 plus 6 cancels out, and we're still left with x. Let's try another one. One function, which I'm guessing this was supposed to say f of x equals negative 3x plus 9, and the other one is negative 1/3 x minus 3. So let's take g's equation, and we'll put it into f's function. So we'll say f of negative 1/3 x minus 3 equals negative 3x. Now this, the negative 1/3 x minus 3, that's our new x. So I'm going to put that all in parentheses. Minus 9. So again, all we did was take its equation and substitute in for x. We put in the other equation for x. We're going to hope to solve this, and hopefully it just comes out to x. Negative 3 times negative 1/3 come out to positive 1x. Negative 3 times negative 3 is positive 9, and then we have that minus 9. 9 minus 9 cancel each other out, so we're just left with x. They are indeed inverses. Yes! I think that's it. Let me double check. Oh, yeah. That's it.